Why does a solution have a lower vapor pressure than the pure solvents? So let's use water as an example. Um, so we have a cup of water, and this is 100% pure solvent, such as water. Um, if we take a look at the surface molecules, water molecules, we learned that some of these molecules have enough kinetic energy to vaporize, to go from the liquid phase to the gaseous phase. And as they build up there, that's known as the vapor pressure of the vapor of the liquid. So they're going to collide back, and some of them will lose that kinetic energy from the collision and go back into the liquid phase, and so on. So they have water, by the way, has a very low vapor pressure as it is because the hydrogen bondings, the intermolecular forces are strong. All right, so let's compare this to a solution. So this is, let's say it's 90% solvent. Again, we'll use water as an example, and let's say it's 10% some kind of solute. It can be sugar or salt. And we'll again take a look at the surface molecules. That's where evaporation or vaporization happens. Oh, I forgot my E. Go. What? Here are my water molecules, and now there's some salt. And now there's some solute molecules in there as well at the surface. So you can already see there's not as much ratio or proportionally as much water molecules at the surface. So there's just going to be less less molecules of the solvent, in this case water, to vaporize. So that's going to lower the vapor pressure. Whenever you add a solvent, whenever you add a solute. And by the way, this is important to note that the solute has to be a non-volatile solute. What that means is it can't have a vapor pressure of its own. I mean, if this vaporizes, then that we're talking about a whole different scenario. So salt, sugar, these sort of solutes, they're non-volatile. They don't contribute to the vapor pressure, which is why adding them will always lower the vapor pressure, because it's always going to be less than the vapor pressure of the pure solvent. And just to take this one step farther, we know that the boiling point, as we defined it in class, is when the vapor pressure equals the atmospheric or external pressure. So when we lower the vapor pressure, we can't change the atmospheric pressure. Right? That the air around the Earth is not going to change because of what we're doing. So therefore, we're going to have to raise the energy to produce more vapor, so this equalizes. So that lowering the vapor pressure means the boiling point will increase as well. So anytime you add salt, sugar, or anything that's soluble, non-volatile in the water, is going to increase the boiling point of that solvent.